Under the burning sun of North Africa in 1942, American infantry first encountered a sound that seemed to slice the desert air apart. It wasn't the crack of a rifle or the boom of artillery. It was a harsh, continuous shriek, like canvas being ripped to shreds by a furious, mechanical beast. Troops who heard it described it as unnatural, almost inhuman. That merciless noise came from Germany's MG42, a machine gun that would soon earn a reputation as one of the most terrifying weapons ever fielded in modern combat. To the soldiers on the receiving end, it seemed less like a firearm and more like an automated instrument of destruction, an engine designed to hurl death at a rate no one had imagined practical. By early 1943, the U.S. Ordnance Department managed to seize one of these weapons intact and bring it home for closer study. Engineers handled it with a mixture of awe and disbelief. What they found inside its stamped steel frame would reshape American thinking and reveal how even a fraction of an inch could doom an entire weapons program. By the end of 1943, after months of evaluation, the U.S. Army expressed confidence that a version of this German marvel could be recreated on American production lines. More than 3,000 conversion kits were ordered, and by January 1944 the first two American-built prototypes arrived at Aberdeen Proving Ground. Hopes were high. Expectations were enormous. Yet the reality was brutal. The first gun sputtered to life long enough to fire a single cartridge before freezing solid. Its bolt locked around a spent casing it refused to release. The second prototype managed bursts, brief flashes of promise, before collapsing into a series of feed failures and extraction breakdowns. After 1,583 test rounds and 51 recorded malfunctions, the experiment was halted. By March, the project was quietly shelved. The United States had attempted to clone Germany's most feared infantry weapon and failed. And the reason was not in the visible components or the stamped steel or even the roller locking system everyone tried so hard to replicate. Instead, the fatal flaw measured roughly 1/4 of an inch. Back in February 1943, when the first captured MG42 was tested and analyzed, American officers were stunned by what they discovered. Unlike the meticulously machined American firearms, the MG42 was a product of rapid wartime manufacturing. Its body was shaped from pressed sheet metal, spot welded and riveted, techniques American gunmakers largely avoided, believing they were cheap and inferior. But the Germans were ahead of their time. Their design allowed a machine gun to be built faster, cheaper, and in far greater quantities without sacrificing battlefield performance. The weapon boasted a rate of fire hovering around 1,200 rounds per minute, nearly double or triple what Allied troops were accustomed to. A quick-change barrel system allowed an overheated barrel to be replaced in seconds without tools. Its belt-feeding mechanism ran with startling reliability. American soldiers initially mocked the MG42's stamped appearance, comparing it to a toy or a piece of farm machinery. That attitude did not last long. Once troops faced it under fire, the laughter ended immediately. Wherever German infantry entrenched themselves, whether in the deserts of Africa, the stony ridges of Sicily, the mountains of Italy, or the hedgerows of France, the rasping scream of the MG42 soon echoed across the battlefield. To the Americans, it became Hitler's buzzsaw. Others called it Hitler's zipper. The British used an older nickname, Spandau, a term that had survived from the Great War. German soldiers themselves had darker names: Bone Saw, Saw of Death, Hitler's Harp. The Soviets had their own label, the Linoleum Ripper, a description inspired by the weapon's unmistakable auditory signature. A Browning automatic rifle fired in slow, methodical pulses around 450 rounds per minute. The Browning M1919 fanned out 400 to 600 rounds. The MG42 doubled all of that effortlessly. Some variants even reached 1,500 rounds per minute. It was less a gun and more a conveyor belt of lead. Infantrymen quickly learned to time their movements around the brief moments when MG42 crews paused to swap barrels or change belts. Those fleeting seconds were the only opportunities to advance under its storm of fire. German teams, drilled to perfection, could perform those tasks so rapidly that the respite often lasted no more than the blink of an eye. After engagements, American officers examined captured German equipment. Again and again, the MG42 stood out as a masterpiece of wartime engineering. It wasn't beautiful. It wasn't polished. It wasn't even constructed in the traditional style of American weapons. Yet nearly every measurable performance category favored the German gun. The origin of that brilliance traced back to 1937. When the German army requested a new universal machine gun that was simpler to build and faster to manufacture than the MG34. Several companies submitted designs, but the winning model came from a firm best known for manufacturing sheet metal lanterns. Grossfuss AG had never made a firearm in its life, yet under the direction of engineer Werner Gruner, the company developed a roller locking mechanism that would revolutionize automatic weapons. Gruner was not a gun designer by trade. He specialized in mass production. He attended a machine gunner's course to learn firsthand what soldiers needed. Then he fused battlefield practicality with manufacturing efficiency. The result was ingenious. A gun built from two stamped steel halves, welded together like a clamshell. A recoil-operated locking system using rollers to stabilize the bolt. A muzzle device that recycled gas pressure to assist cycling. An adjustable rate of fire. And a barrel that could be dropped out and replaced with astonishing speed. Every piece was designed for simplicity, reliability, and rapid assembly. Development accelerated quickly. By 1938, the prototype impressed the German army enough to request refinements. The improved MG39 emerged, followed soon after by a limited run of pre-production MG39/41 models that saw combat testing by 1941. In early 1942, the finalized MG42 entered mass production. Contracts spread to multiple factories across Germany and its occupied territories. The weapon debuted with the Afrika Korps in May 1942 and swiftly spread across every major front. Production numbers soared. Nearly 18,000 units in 1942, more than 100,000 the next year, over 200,000 in 1944, and tens of thousands more in 1945. In total, more than 400,000 MG42s were produced before the war ended. By 1943, MG42 output surpassed that of the older MG34, cementing its place as Germany's primary infantry support weapon. America took notice. They wanted one of their own. The MG42's blend of speed, simplicity, and manufacturing efficiency was unlike anything in the U.S. arsenal. American machine guns required extensive machining and precise crafting. The MG42 could be stamped out rapidly with fewer man-hours and less material. It seemed like a perfect candidate for mass production. Throughout 1943, U.S. engineers continued examining captured MG42s. Eventually, the War Department issued a directive. Reverse engineer the weapon. Modify it to fire .36 Springfield ammunition. Test it, and if viable, put it into large-scale American production. The contract was handed to the Saginaw Steering Gear Division of General Motors, an automotive company already drowning in wartime assignments, from M1 carbines to artillery components. The MG42 conversion became a side project, but expectations remained high. Saginaw's engineers meticulously measured every surface, traced every contour, photographed every component, and studied the roller locking system that made the MG42 operate with such ferocious speed. They kept the general architecture, the stamped construction, the recoil operation, the belt feed, and the quick change barrel system. They designed it to fit existing American tripods. But they changed one crucial thing: the ammunition. The original MG42 chambered the German 7.92 multiplied 57 Mauser cartridge. The American version, designated the T24, was modified to chamber the 36 Springfield, a cartridge nearly the same power but slightly longer. To compensate for the higher impulse of the American round, the engineers replaced the German gun's 17.8-ounce bolt with a massive 47-ounce counterpart. This was intended to slow the rate of fire to levels more consistent with American doctrine. Theoretically, it should have worked, but a hidden detail unraveled everything. The German cartridge measured approximately 3.228 inches. The 36 measured around 3.34 inches, about a quarter of an inch longer. It sounded insignificant. In reality, it was disastrous. The longer American round demanded a slightly longer bolt travel to extract and eject properly. But Saginaw's engineers didn't extend the bolt's rearward movement in proportion to the longer case. This microscopic oversight disrupted the precise timing required for the roller locking system to function. The MG42's timing was razor sharp. Every fraction of a millimeter influenced the way rollers engaged, how the bolt unlocked, how quickly spent casings cleared the action, and how smoothly the next round fed. With the chamber modified, but the bolt travel not recalibrated, everything fell out of sync. The gun fired, but the bolt didn't retreat far enough to complete extraction. Cases stuck. Ejection failed. Feeding became erratic, and the heavier bolt compounded the mismatch, throwing the entire cycle into chaos. When the two T24 prototypes arrived at Aberdeen in January 1944, the problems became immediately obvious. The first prototype jammed after one shot, refusing to clear its first spent casing. Engineers tore it apart, tested it again, and watched the same failure repeat. The second prototype managed bursts, but suffered an unending stream of stoppages. Its peak performance averaged around 600 rounds per minute, barely faster than existing American designs, and nowhere near the MG42's blistering speed. For over a month, test personnel tried every possible improvisation. They swapped extractors, polished feed ramps, replaced bolts, and adjusted springs. Nothing helped. By February, with more than 50 serious malfunctions recorded, the trials were permanently halted. A month later, the Army concluded that the weapon required fundamental redesign before further testing. With the end of the war approaching and priorities shifting, the program was quietly abandoned. The core failure lay in one overlooked fact. The MG42 was engineered around the exact dimensions of the 7.92 multiplied 57 cartridge. The entire system, bolt mass, spring tension, travel distance, roller timing, extraction geometry, was tuned to that cartridge alone. Stretching the chamber to fit a longer round without recalibrating the bolt travel destroyed the mechanical harmony on which the MG42 depended. In a machine cycling 20 rounds per second, a fraction of an inch was the difference between flawless operation and catastrophic failure. American engineers assumed the cartridge difference was negligible, a minor detail easily overcome with a heavier bolt. Instead, that quarter-inch turned a legendary weapon into a single-shot curiosity. Meanwhile, on the battlefields of Europe, real MG42s continued dominating firefights. Their terrifying sound echoed through the hedgerows of Normandy, the frozen forests of the Ardennes, and the ruined cities of Germany. The weapon functioned reliably under mud, ice, sand, and heavy snowfall. Even Allied soldiers who never faced one in combat knew its reputation. Captured examples were treasured trophies, though rarely used in battle due to ammunition shortages. The irony was bitter. Germany's cheapest, fastest-produced infantry weapon consistently outperformed more complex Allied designs. And while American industry had the resources and expertise to build almost anything, the nation could not successfully replicate a weapon whose brilliance lay in its invisible precision. The T-24's collapse influenced American weapons design for decades. When the United States developed the M60 machine gun in the 1950s, designers borrowed heavily from the MG42's belt feed system and incorporated ideas from the German FG42 rifle. But this time, the gun was purpose-built around the 7.62 × 51 NATO cartridge, not retrofitted to an incompatible system. The M60 had its own problems: weight, fragility, complicated barrel changes, but at least it functioned reliably. The MG42's lineage continued worldwide with far more success. West Germany rechambered the design for NATO ammunition, creating the MG1, MG2, and eventually the MG3, which still serves today in many nations' armed forces. Yugoslavia produced its own version, the M53. Austria crafted the MG74. Italy and other nations adopted variants or licensed copies. The basic German design needed almost no revision when properly matched to its intended ammunition. Today, the MG42 stands as one of the most influential firearms ever created. Its roller locking system inspired numerous post-war weapons. Its stamped construction pioneered manufacturing methods still used in modern small arms. Its rate of fire became a benchmark, and its terrifying battlefield presence left a psychological legacy unmatched by most infantry weapons. The American T24, on the other hand, survives only as a historical footnote, an example of what happens when engineers focus on what they can see but misunderstand the deeper mechanics beneath. A museum piece today, it reminds us that copying a machine is not the same as understanding it. The MG42 was not simply a collection of steel parts. It was an intricate choreography of timing, movement, and pressure. Every dimension mattered. Every fraction of an inch played a role. Change one value by a sliver, and the whole performance fell apart. American troops who survived battles in North Africa, Italy, France, and Germany often said they could never forget the MG42 sound. It symbolized the raw brutality of mechanized warfare, a sound that pinned men to the ground, tore apart units, and shaped the tactics of entire campaigns. When the U.S. Army attempted to duplicate that power, they believed they could do so simply by mimicking the outward design. But they overlooked the hidden refinements, the exact mathematical relationships between chamber length, bolt movement, roller engagement, and cartridge dimensions. That quarter inch, the tiny increase in cartridge length, became the dividing line between the deadliest machine gun of the Second World War and an American prototype that could barely fire. In the end, the story of the MG42 and the failed T24 conversion teaches a simple lesson. Engineering triumphs not through imitation, but through understanding. The Germans spent years perfecting the MG42 before mass production. The Americans, overwhelmed with wartime priorities, tried to rush a shortcut version into existence. One nation tuned every detail to perfection. The other assumed perfection could be copied like a blueprint, and in the heart of that assumption lay the downfall of the T24.